Welcome to a new video from the Tech Talk channel. Today, we'll be talking about the principles and algorithms of artificial intelligence. We hope you enjoy this information and find it useful. So, let's dive right in. We're gonna peel back the curtain on the AI revolution. We'll look at how these incredible models actually work, what they might be able to do for us, and, well, the huge challenges that come along with building them.
All right, let's kick things off with this quote from Dario Amodei, the CEO of Anthropic. And we're starting here for a reason, because it gets right to the heart of it all. You see, AI, it's not just about cool tech or smart algorithms. At its core, it's about power. So digging into how this stuff works, that's not just for engineers. It's for all of us, because we need to understand who's shaping our future and how. All right, first up, the engine of progress. How on earth did these AI models get so smart so fast? The core idea behind it all is, honestly, it's surprisingly simple, but its impact, absolutely world-changing. And here it is. This is the big secret, the scaling hypothesis. For the longest time, everyone in the field was searching for some brilliant, completely new algorithm. But it turns out that wasn't really it. The answer was just more. You take the models we already have, you make them way bigger, you feed them a huge chunk of the internet, and you throw an insane amount of computing power at them, and what happens? Their performance just goes up, predictably. And the leaps they make aren't just small improvements, they're often totally shocking. I love this quote from Ilya Sutskever, one of OpenAI's co-founders. They just want to learn. It really captures the almost magical, kind of weird feeling of this whole scaling thing. It's like, if you just provide the right conditions, tons of data, tons of compute, these systems have this unbelievable, almost natural drive to find patterns and absorb information. It feels like they just learn. So that's the big idea, but how does it actually happen in the real world? Well, it boils down to this pretty standard engineering process. First, you get the data, and I mean a massive amount of it. Then you train the model, that's where all that scaling we just talked about comes in, and finally, you deploy it. You put it out there so people can actually use it. This simple little loop, this cycle, is how that big abstract idea of the scaling hypothesis turns into the AI tools you and I use every day. Okay, so we figured out how to make these things super, super smart. Awesome, right? Well, yeah, but it also creates a huge new problem, a really big one. We've basically built these incredibly powerful digital minds, but we don't fully know what's going on inside them. It's a black box. And that begs the question, how do we make sure they're actually doing what we want them to do? And this is really the million-dollar question, isn't it? We're building these systems that can do amazing things, but can we really trust something if we don't understand it? It's like we can see the answer it gives, the output, but the process of how it got there, that's the mystery. And if you don't know the how, then trying to make sure it's safe and reliable and, not going to do something crazy, that becomes unbelievably hard. So how are researchers trying to crack this black box? Well, there are basically two main paths they're going down. The first is the behavioral approach. Think of it like being a psychologist for an AI. You look at what goes in and what comes out, and you try to figure out its behavior. The other path, the mechanistic one, is way more intense. It's like being a neuroscientist, trying to actually map out the circuits inside the AI's brain. The researcher Chris Olah has this perfect analogy for it. He says it's like trying to reverse engineer a compiled computer program. You've only got the finished product, and you have to work backward to figure out the source code. It's an incredibly difficult puzzle. Now, while the deep science of reverse engineering these models is going on, labs need solutions today. And one of the really clever ideas coming from Anthropic is something called constitutional AI. The basic idea is brilliant. Instead of having a human babysit the AI and approve every single output, which is just impossible to scale, you give the AI a set of rules, a constitution. And then you train the AI to judge its own responses against those rules and fix them. It learns to self-correct, which is a total game changer for making this whole alignment thing practical. Okay, so we've talked about how these things learn and the massive challenge of keeping them safe. But now let's get to the really exciting part, the prize. What's the payoff for all this work? Let's talk about the new frontier of what AI could mean for science, for creativity, for everything. This quote from Dimas Hassabis at Google DeepMind it's just mind-blowing when you really think about it. What he's saying is that the universe isn't random. Nature, biology, physics, it all has a structure. It follows rules. And if it follows rules, a powerful enough neural network should be able to learn those rules, just by looking at the data. Think about that. AI could become the ultimate tool for figuring out how reality itself actually works. And just to be clear, we're not talking about some far-off science fiction fantasy here. These are the actual, concrete goals that the top AI labs are pouring billions of dollars into right now. I mean, imagine being able to simulate an entire living cell on a computer to see how diseases work, or discovering new drugs and materials not in a lab but inside a simulation, or playing a video game where the world is so alive it literally builds the story around you as you play. This isn't just about making things a little faster, it's about completely changing the speed of science itself.
So what kind of speed up are we talking about? Well, a number that gets thrown around is 100x. Imagine that, 100 times faster. Think about drug discovery. Right now, a scientist might spend weeks setting up and running one single experiment in a wet lab. An AI could run thousands, even millions of virtual experiments in that same amount of time, finding the most promising ideas before anyone even picks up a test tube. The amount of time, money, and frankly, human lives that could save is just staggering. But, and this is a huge but, with that kind of incredible potential comes incredible risk. As these systems get more and more powerful, we run headfirst into the grand safety challenge. How in the world do we manage this kind of power responsibly? And again, we're not just talking about Hollywood movie plots with evil robots. Dario Amodei and others point to very real, very near-term risks. Think about it. An extreme concentration of power in the hands of just a few companies. The potential for misuse is terrifying. What if someone uses an AI to help design a new virus or to launch a massive cyber attack? And then there's the biggest, most fundamental challenge of all. Our technology is growing exponentially, but our wisdom, our ability to manage it, isn't. We're in a race against our own creation. So to try and get a handle on this, labs are developing frameworks, kind of like a hurricane category system for AI. This is Anthropic's version, the AI safety levels, or ASLs. It's pretty straightforward. Level 1 is basically harmless. Think of a chess bot. No big deal. We're right around level 2 right now with models like ChatGPT and Claude. But the jump to ASL 3 is where it gets serious. That's an AI that could, say, help someone who's not an expert do something pretty dangerous. And ASL 4 and beyond, well, that's where you get into potentially catastrophic risks, like AIs that could enable massive attacks or even start acting on their own. And the safety measures we need for each level have to scale up just as fast, if not faster. Which brings us right back to the biggest question of all, the one that hangs over everything we've talked about. The technology is on a rocket ship, accelerating faster than we can comprehend. But our wisdom, our societies, our governments, they move at a walking pace. How do we close that gap? How do we make sure our wisdom catches up to our power? Answering that is probably the single most important challenge of our generation, because the future we get depends entirely on it. Thanks for tuning in.